Hi everyone. Today we're going to be talking about day 2 of dividing polynomials, and we're specifically talking about synthetic division today. Now, unlike long division, synthetic division can't be used on every single polynomial. It only works in a special case. But when this special case occurs, which it does very often, then it's a quicker, more efficient way to do division. So the special case is that the divisor, the thing that we are dividing by, has to be in the form of x minus k. And so there cannot be a coefficient or an exponent on our variable, on our x term, or whatever our variable happens to be, other than we can, of course, have that invisible 1. So we don't normally write the one that's here and the one that's here, but those are the only coefficients and exponents we can have. K itself can be positive or negative, and it's called the house number. So you see a negative sign here in the expression, but the K value that is plugged in there can be positive or negative. Let's take a look at the steps that we're going to use to set up our synthetic division problem. So the first thing that we'll do is our synthetic division bracket, kind of a half box here, the left and bottom sides of a box would need to be written. And then once we do that, we're ready to go through our steps. The first step is to write the house number using the divisor. Remember that it's going to be the opposite sign of what you see in the expression of x minus k. So we will write k itself out on the outside of the box. And this box, you want it to be 2 lines high. You're going to write 2 lines of numbers. The second thing you're going to do is fill in that first line of numbers, which is the coefficients of the dividend. Coefficients only, not the x's or the exponents. And just like with long division, we will use a 0 for any missing powers. So we're going to write all of our coefficients across here, making sure you leave plenty of space between them so you can tell where one number starts and the next one ends. Then we will bring down the first coefficient into the quotient. We're going to be building our quotient down here below the line. So whatever our first coefficient is, we're going to rewrite it down here in the quotient, and then take that number that's right here, that first piece of our quotient, multiply it by the house number. So we're going to bring down the first number and then multiply it by the house number. And we'll write that up here. That's going to fill in this, start to fill in the second line of numbers here. Once we do that, we will add, going straight down and add the 2 numbers, the second coefficient and the number that we just wrote from our multiplying, and then we will repeat the steps as needed. Again, this isn't going to make a whole lot of sense until you see an example, but once you have an example in front of you, I want you to be able to refer back to these steps. So the steps are going to be to bring down, that's step 3 once we start the actual process, M for multiply, and then add. So steps 3, 4, and 5, and then we continue to repeat steps 4 and 5 only as many times as we need to. So ba mama, 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 until you run out of numbers. There are some things to remember, to keep in mind as we go through the problems. I'll be referring back to these as we start working our examples, but again, I want you to have a written record of it so that it will make sense once we start doing the examples. So the first thing to know is that the last number that you write, the one that's on the furthest right in the quotient area, is the remainder. And so we're going to separate that from the rest of the quotient with a vertical line, to make sure that we remember that that's partitioned off and that the remainder will be written divided by the divisor. After we identify the remainder as the furthest right, we're going to continue reading from right to left. I know that that's backwards, but we don't know what our biggest exponent is, so we can't start on the left. And the next number of the quotient is going to be our constant, that number only that does not have a variable. And then after that, the third term from the right will be the plain x or plain variable term or x to the first power, you might think of it. And then we'll have an x squared, an x to the third, and then an x to the fourth, etc., however many we need until we run out of numbers. We'll then put our coefficients and our variables back together with their exponents, and we will write the solution as the quotient plus remainder over divisor, which is the same format that we used with long division.